people, and welcome. In today's video, we will be talking about the very basic adding and subtracting non-negative numbers. Now, the non-negative numbers are also known as natural numbers. And there are some inconsistencies with the definition of natural numbers. So some of the mathematicians will say that, hey, natural numbers are positive numbers. Well, both of them agree with that, but some will say positive numbers. 0 is neither positive nor negative, therefore 0 is not a natural number. However, there will be other mathematicians that say, hey, natural numbers are your counting numbers. So since 0 is on a number line, it is one of your counting numbers. Therefore, yes, 0 is included in your natural numbers. If you Google if 0 is a natural number or part of the natural number set, it literally reads, and I quote from Google, 0 is not positive nor negative. Even though 0 is not a positive number, it's still considered a whole number. So to answer the question, is 0 a natural number? Yes, it is on a number line when identifying numbers in a set. But also no, because it's not used to count objects. So you won't say there's 0 amount of apples, you just don't count it. So we are going to assume that 0 is a natural number and include that in our set. So non-negative natural numbers for us, we're going to start with 0, 1, 2, 3, and we're going to continue that and close that off. Okay, so why is that important? It's because we're going to add and subtract these natural numbers. So let's start with example number 1. Let's start with something that I am sure 100% every single one of you did back in elementary school. So we're going to do something like 5 plus 3. So we are adding these numbers. We're doing a plus. There are multiple ways of how you were taught this. One of the ways would be a number line. So let's do a number line here. Here's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9. And you can keep going if you need to. And so one of the ways that you are taught to add is to go to the first number, which is 5. So here it is. Here's 5. And then you're adding 3 more. So I am increasing by 3. So 1, 2, 3. Where am I? I am at 8. So that is one way that you could have been taught adding natural numbers. Another way that you could have been taught is by the drawing method or by counters. So you have 5 of something. So let's do 5 circles. Ooh, that pen doesn't work. Let's try another one. 1, 2, 3, 4, 5. I have 5 of something. And I have 3 more of the same type of something. So notice the 5 and 3 are both natural numbers, so we're going to use the same symbol, in this case circles, in order to show that we have 5 of something and then 3 of something. So then 5 and 3, 1, 2, 3, 4, 5, 6, 7, 8, we have 8. Another way, I'm not going to draw it out, but it's using your fingers. Here you go, my hands. So here's 5, 6, 7, 8. So I have 5 and then 3 more. Whichever method that you would prefer, use that method. In my class, I always encourage you guys to use your fingers whenever you can when you are counting. They can not allow you to use a number line. They cannot allow you to draw this, but no one's going to take away your fingers in order to count. I do that with multiplication. I even do that in trigonometry, the left-hand trig for trig values. Make sure that you are comfortable with adding. Now, adding 5 plus 3 is a little bit on the easier side. It's more like a level 1 question. So let's jump it up to something like a level 2 question. So example number 2, I'm going to change that to a different color. Color code it. Level 2 question would be example number 2. And let's do something with double digits. Let's do 23 plus 18. Now, 23 plus 18, I could use the number line. I could use this method here I call this method the counter method because we're literally counting like that. Or I could use my fingers. However, it's going to take me a very long time to get to 23 and then get even to 18 more than 23. That's just going to take too much time. So whenever we have two right here, 2 digits, I'm going to show you another way that you can do it. You can split this up. For example, I know that 23, let me change colors again so that way you can see what I'm writing. Sometimes pencil doesn't show up on here. All right, so we know that 23 is 20 plus 3. I also know that 18, I'm going to keep this plus here. I'm going to change that color in just a little bit. I also know that 18 is 10 plus 8. This plus is this plus. I split up 23 and I split up 18. Now, why did I do that? Because I personally don't know what 23 plus 18 is. I have absolutely no idea. However, 20 and 3 is 23. I know that. And I know that 10 and 8 are 18. So now what I can do is I can combine different pieces by solving things I do know. For example, I know that 20 and 10, that's 30. I know that 8 and 3, maybe I don't know this. So let's use our fingers. 8, 9, 10, 11. I'm going to bring this one down. So now 30 plus 11, if you know that one already, go ahead and solve it. Now, if you don't know that, you can keep splitting it up. You can split it up in however many different ways as you want. So, for example, if you don't know what that is, I'm going to keep 30 because that's a pretty number. However, I'm going to split up 11 to 10 plus 1. So now, once again, I have 30 plus 10, that's 40. I have plus 1. So then this equals to 41. I'm going to write the answer here, put a box around it so that way we know since we're dealing with a lot of different numbers here. Now that did take me a little bit of time. Obviously, it would take me a little bit less time if you just kind of go through it instead of, talking through it. But let me show you the traditional way. This is not the way that I was taught. I think this is an incredibly useful way of doing it. You can use this exact same method when you're multiplying. But the traditional way is as such. So I'm going to put a thinking bubble here since there's room. And a thinking bubble, again, if you don't recall, if you're not in my class, it's just we're thinking about it. These are our steps that we could potentially take. We're thinking about it. So this is what I'm thinking. The traditional way is 23 plus 18, and we're writing it in a column format. Now, if this is the way that you were taught, this is the way that I was taught, that's great. Use this method. Choose the method that works for you. So in this case, we separate them in terms of placement. So 8 and 3 are on the same placement. And what I mean by that is 8 and 3 are both in the tens position. Excuse me, ones position. Let me back up a little bit. I think I spoke that a little bit not clear. Okay. We have the ones positions, the tens positions, and then after that, if we have more numbers after that, that would be in the hundredths position, okay? So since these are the first, we're going to just add them. So 8, 9, 10, 11. Now I can't write 11 here. That would be incorrect because when we write 11, so here it is, 8 plus 3 is 11. 11 has a 1 in the tenths position, and then the other one in the ones position. So we want to put the 1 in the ones position and then put the other one in the tens position. Now you can't really see it, but I did draw a little dashed line here to separate it. There you go. You can see that a little bit better. Now that we have our ones taken care of, now we have in the tens position. So 2, 3, 4. I'm going to just write it again. That way it's not separated, and we have 41. Make sure that if you have a double-digit number when you are adding in a column, that you carry whatever number is in that tens position over to the next one. Now you could do that same thing with things in the hundreds place. So let's do another example. I'm trying to color code these. Let's see what color I have not used. All right, let's try one more. Example 3. Oh, I don't know. Let's try 537 plus, I don't know, 602. 612. Just kidding. All right. You can do the exact same thing as we did in example number 2. You can choose to split it up this way. You can choose to do columns. Since I split it up first in example number 2, I'm going to choose the column method first in this example. So what I'm going to do is I'm going to rewrite it as 537 plus 612. Again, you have your columns 7, 8, 9, 3, 4, 6, 7, 8, 9, 10, 11. Now, you may say, hey, you need to carry over that 1, because remember how I said that once you get into double digits, that first term, that term before needs to go to the next column. So imagine there's a column here and there's nothing else here. So I'm going to bring that 1 and then put our 11. The trick is if you don't have any numbers to the left, just write whatever it is. So the answer is 1149. So 1,149. Let's see if we can get that same answer with the other method. So again, that method is to split things up. So let's split up 537. I know that's 537 and 612. Now you can choose to do 12 if that's simple enough for you, or you may choose to do 10 plus 2. I usually like to split it up into 10 plus 2. So I'm going to start adding things up. 500 plus 600, that is 1100. 30 plus 10 is 40. 7 plus 2 is 9. So I have 1149. Again, whichever method you prefer is fine. Go ahead and use that. So that is just a quick, brief review on how to add natural numbers. So let's go through how to subtract them. Subtracting them may be a little bit more difficult for some of you, maybe not. It might be the same. If you are struggling with this, please let me know in advance, so that way we can work on it one-on-one and I don't lose you, because we're going to move quickly after this. All right, so let's start with the same thing. So let's start with subtraction. Example 1. Example 1, we had 5 plus 3, so let's do 5 minus 3. Again, you may choose to use a number line. Number line will come in handy whenever we are working with integers, so with negative numbers. Counters will also help. So let's do one at a time. I kind of got ahead of myself. So let's do 5 minus 3. So here's 0, 1, 2, 3, 4, 5, 6, 7, 8. All right, let's start at 5. Here's 5. And so minus 3. So we're going to take away 3. Or what you can say is go left. So this negative, this minus, tells you to go towards the smaller number. So you're going to go left 3 jumps. 1, 2, 3. So you're at 2. So let's do the counters. Notice that I put 5 counters here, so 1, 2, 3, 4, 5. We're going to take away 3. Now, this is important, kind of foreshadowing what's happening in maybe the next lesson or the following lesson after that. We're going to take away 3 positives. So 3 is a positive. It might look like 3 is a negative, but we're going to take away 3 positives. So we have 5 positives or 5 circles. We're going to take 3 of them away. So in my class, in order to show that something cancels out or takes away, we're going to go 1, 2, 3. So what's left? That is 2. 2 is left over. I'm debating right now if I want to show you something else. I'm going to leave it. We're going to talk a little bit more this type of problem when we talk about negatives. All right, let's do example 2. For example 2, I had 23 minus 18. Now for subtraction, you can do split them up. I, however, don't prefer that method, so I'm not going to teach that to you. If you would like, come in for tutoring, and then you and I can spend some time on it. But when you're subtracting, I highly recommend doing it this way, and that is you can write it in column form. So we're going to say 23 minus 18. Again, some of you are having flashbacks to elementary school, but this is how we're going to do it. So we're saying, hey, do we have enough to take away? So the way we're reading it is 3 take away 8. So I have 3 of something. I need to take away 8. Do I have enough? No. So I need to borrow from my neighbor. So since I don't have enough, I'm going to borrow from my neighbor. I'm going to be like, hey, neighbor, what you got for me? And the neighbor's going to be like, hey, I have 2. Technically, it's 23. So I have 2 10s. I can give you one of those 10s. So my 2 10s, or my 20, is now a 1 10. So this is in my tens place, and this becomes 13. So now I'm saying, hey, I have 13 now. Can I take away 8? Yes. And again, I don't know this off the top of my head, so I use my fingers. For example, I count up. So I said 13 minus 8, I don't know what that is, but I know that 8 plus 9, 10, 11, 12, 13. 8 plus 5 is 13. Now I'm saying in my tens place, I'm saying 1 take away 1. Yes, I have enough. So if I have 1 and I take away 1, done. So therefore, 23 minus 18 is 5. You can also, if the numbers are small enough, you can also use that method. So example, another way, let's do a thinking bubble. 18 plus what is 23? 18, 19, you can't see it, but I'm counting using my fingers. 18, 19, 20, 21, 22, 23. 18 plus 5 is 23. And we can do this because addition is the opposite of subtraction. If subtraction is the opposite of addition. By opposite, we say undoes each other. So that way,